Hi, welcome to lesson number 2, module 3 of the Apache Spark and Scala course. So in this particular session, we will be learning how to create an RDD. Now before we proceed with the lesson, let's have a quick recap of the previous lesson. So in the previous lesson, we have learned the concept of RDD, the difference between DSM and RDD, why someone should go for RDD, and how RDDs can be effective in solving iterative and interactive queries. In this particular lesson, we will be understanding the building blocks of RDD, how to create RDD, and what are the different ways in which you can create an RDD. So when you look at the building blocks of an RDD, there are 5 main building blocks. You have partitions, compute function, dependencies, metadata, and partitioner. Now the metadata and partitioner are optional. Let's see what they are in detail. Now an RDD must have a set of partitions. So like I have explained in the last lesson, every RDD has some data, and this data will be partitioned into small chunks, and this is called a partition. An RDD should also have a set of dependencies. So the whole operation of Spark happens through DAG, or the directed acyclic graph. So there has to be a lot of dependencies between RDDs. And the RDD must also have a function to compute the partitions. So when you say that you need 3 partitions, or even if you are working with the default partitions, it needs a function to calculate the partition. And the optional metadata tells about the scheme of partitioning and data placement. And the partitioner is used to define the strategy for partitioning. Now there are 3 ways in which you can create an RDD. The first one is to parallelize an existing collection. Now Spark Core provides a method called parallelize, which you can use on any existing collection to create an RDD. Which means if you already have a collection, a Scala collection, for example, you can use the parallelize method to create an RDD from the existing collection. The second way is from external datasets such as HDFS, flat files, NoSQL databases such as HBase, Cassandra, so on and so forth. The third is to create an RDD from an existing RDD. Well, obviously RDDs are immutable. That means you can always create another RDD from an existing RDD. So let's dive deeper into these different types. So the first way is to do the parallelize collection. Now Spark Context has a parallelize method which allows you to convert any existing collection into an RDD. Now the elements of your collection will be copied from a distributed datasets, and they will be operated in parallel. So let's see how to use this method to create our first RDD. So here you can see that I am creating a variable called data by typing val data equals array 1, 2, 3, 4, 5. So this creates a collection which is array which has elements 1 to 5. Now if I want to create an RDD from this array, I can simply say val and any name. So here I am using list RDD equals sc.parallelize and then the collection name, which is data. Note here that sc is your Spark context, and this is by default available in the REPL. Parallelize is the built-in method. So in the Spark context, we are using the parallelize method on the data collection, and as you can see, it immediately creates an RDD. So here you can see list RDD is org Apache Spark RDD. And then once you have an RDD, you can perform some action on the RDD. So here I am typing list RDD dot reduce a comma b, rocket symbol a plus b. So basically I am using the reduce transformation here. We will learn about transformations a lot, and then I am generating a result of 15. So basically what happens here is that the reduce action takes individual elements and add them together. The next way in which you can create an RDD is from external data. Now, Spark supports a wide variety of external data sets to be read and created into an RDD. It can be local file systems, it can be shared file systems, it can be file systems such as simple storage service offered by Amazon Cloud, it can be your Hadoop file system, it can be NoSQL databases. Also, Spark allows different types of files to be read into an RDD, such as normal CSV files, text files, flat files, sequence files, JSON, XML, so on and so forth. Now, to create an RDD by reading data from the external data, you have to use the text file method. Now, don't get confused by the name. Text file does not mean it can read only text file. The text file method can actually read flat files, CSVs, JSON, so on and so forth. Now, this method actually takes your URL and read it as a collection of lines. Now, Spark actually supports 3 categories of files: the text file, sequence file, and other Hadoop input formats. So when I say text file, this will include normal text files, CSVs, JSONs, and so on and so forth. The second type is sequence file, and the third is other Hadoop input formats. Now let's see how to reference to an external dataset using the text file method. Now the method is called text file, and here are a few pointers which you have to take care. First of all, when you are using the text file method, the file must be available at same location on worker nodes. Now it can be on the local file system or another file system such as Hadoop. All file-based input methods of Spark support to work on compressed files and directories. To control the number of partition, text file method also take an optional argument. So if you want to read from an external data set and create an RDD by mentioning the number of partitions, you can pass it as an argument as well. So let's say how to reference to an external data set when you want to read a sequence file. Now a sequence file is a special file format which we use extensively in systems such as Hadoop. Now sequence files usually have a format of a key and value. Now you can also use the Spark context sequence file method if you want to read a sequence file, but what are some of the considerations you have to take care? Now the parameter should be subclasses of writable interface of Hadoop such as text and int writable. So text, int writable, and other subclasses are used extensively in Hadoop to represent the data types of keys and values. And if you have gone through MapReduce, you might be familiar with this. And you can specify native type for common writables. So if you are not able to represent as a subclass, you can simply say sequence file, then integer and string, which are native types. Now, what is the other type of format Spark can read? You can always use something called Hadoop input format. For any other Hadoop input format, you can use the Spark context .hadoop RDD method. Now, this actually takes an arbitrary job configuration and input format, class, key, and value. And Spark context.new API Hadoop RDD can also be used. Now you can use existing Hadoop input formats. For example, I can say sc.hadoop file, key class, value class, input format, and config. So when you will be using this type of data, if you're not able to represent your data using any other format, then you will be using the Hadoop input format. And when you mention the Hadoop input format, you will say sc.hadoop file. Then you have to mention the class which you have used to define the key, actually the subclass, and the value class, and the format, and the job configuration. So let's take an example of creating data from an external file. So here you can see that I'm typing val file rdd equals to sc.text file home skill speed desktop a.txt. So in this example, my data is present on my local file system and it will be read and a file rdd will be created. And when I perform an action on the file rdd, such as file rdd.collect, you can see that it is able to read the file and show the output as well. Now let's look at a practical example of creating an RDD from another RDD. So in the example, you can see that I have an RDD called lines, which I have created using the sc.parallelize method, and I have a list of hi and welcome to skill speed string. So once I have the lines RDD, I can create another RDD from lines RDD. So I'm creating an RDD called a split RDD where I'm using the map transformation. I'm saying that for each line split it using comma. And when I call an action called collect on the split RDD, you can see that I have an array of hi and welcome to skill speed. So this is an example of creating an RDD from another RDD. And this is extensively used since we are using transformations. So to wrap up, in this particular lesson, we have learned about the building blocks of RDD, the RDD creation, and types of RDDs. That's all for this lesson. If you have any questions, please do not hesitate to raise a support ticket. Thank you.